Hi, this is Dave Lipscomb. I am your math teacher for the next 14 days here at presentation. I'm going to be doing a video, hopefully every day, that will help you with the curriculum. These videos are not meant to replace in any way, shape, or form the content provided in class. This is meant to simply enhance what we're doing, maybe remind you of some of the techniques that we learn in class, maybe how to oh, there's my dog. Hi, dog. Hi, Annie. Say hi, Annie. Just helping you along with what we've done. So today what we're going to do is we're going to go over like 11 things that we did in class on day one. And these are going to be things like distribution, combining like terms, ordering real numbers, inequalities, absolute value equations, percent problems, things like that. So what you're going to do is you can just fast forward to the video, and I have headers on the video, and you'll see what I mean, such that you can just fast forward to the section that maybe you need a little more help with, and then skip past the parts that you are not so interested in. So let's just cut over to the drawing pad, which we're going to be using a lot of, and I'll kind of explain to you how this is going to work. So this is our sketch pad here. And I can do, I can draw on this sketch pad, and do math like this. We can do math, and I will be going over these topics today. So we'll just delete what I just scribbled down. So we're going to start with distribution, and distribution is stuff like this. 2 times x plus y, and then what does that equal? Then we're going to talk about separating into 2 fractions. So this is we talked about this today. This is when you have something like 5x plus 20 over 10. How to simplify that, or how to rearrange that, or write an equivalent expression. Combining like terms, 2x plus y plus 10 minus x plus 4y plus 20. These are problems like that. Ordering real numbers. So sometimes you say, well, what's greater? 7 or the square root of 51? Which is greater? Order of operations. This is, 1 minus 2 plus 4 times 6. What does that equal to? And what order? You don't just go left to right. How do you order these operations? Multi-step operations. This is going to be solving equations like 2x equals 10, or multi-step. 2x plus 17 equals 41. How do you solve these type of equations? Or it could be x over 7 equals x plus 2 over 10. Inequalities. These are simply, they're like equations, but they're inequalities. So x plus 2 is greater than or equal to 10. How do you solve that guy? Absolute value equations. X plus 7 equals 14. How do you solve these types of equations? Rearranging formulas will be like 2x plus y equals 10, and you'll say solve for y. Percent problems. These can drive people crazy, but I'll show you a very easy way to never screw these up. So this is like 7 is what percent of 28? That's these kinds of equations, and I'll show you how to do this so you'll never screw it up. And then word problems. These will be. I'll give you a word problem and show you how to write this as an expression, and then as an equation, and then even to solve. I won't write the example out here because it's kind of long. So we're going to go over this one slide at a time. This might take about an hour to get through the whole thing, but maybe you're just confused, or you want to remember how to order real numbers. And then solve absolute value equations, and then maybe percent problems. And so you would just skip through to these slides, and then you'll maybe spend about 15 minutes instead of the full hour. So let's move forward, and we'll start off with distribution. Okay. So distribution is, and again, everything that we're doing today, these are building blocks. These are basic building blocks for algebra. So these are things that most people in the class will know. If you don't know one or two of them, or maybe five of them, then you're gonna have to work a little harder today and practice a little more, use the book and use your examples in the book and your notes from class and the lessons online that we're doing right now in this video, this YouTube video. But you'll get the hang of this pretty quickly, and then we'll be moving on, and the topics won't come quite as fast. Again, these are building blocks, so I'm going to go a little slower. So distribution, what is the key to distribution? Well, when you see a number or a monomial multiplied by a parenthesized expression, what you need to do is you need to find every term inside the parentheses, and you're going to multiply this term on the outside by each one on the inside. I like to draw arrows. So the first thing I like to do is identify every term. So terms are separated, as we discussed in class, by addition and subtraction signs. So here's one term, and here's a second term. We have two terms, because if we have one addition or subtraction sign, then we have the terms of the things that it separates. So we need to multiply this 2 by each term. So we'll just take this 2, this arrow, and we're going to multiply it by each term. Again, I like to draw my arrow so I don't screw this up. So 2 times x is 2x. And then I'm going to move down my sign, plus. And then 2 times y is 2y. And then I'm going to box my answer. And we talked about that in class as well. Boxing your answer. That's the way you've committed to an answer. And so I, as a grader, can see that this is definitely what you've committed to. If you don't box it, or it's somehow not at the end, I can't give you necessarily full credit, because I don't know what you're committing to and saying, this is my answer. Okay, so let's move on to the second problem. And this is the same thing. We have 2 terms, because we have one addition sign. So we're going to draw our arrow to each term. And we'll say, oh, well, 3 times 4a is 12a plus 6b. All right. Now I'd like you to try these next 2 on your own. If you're getting the hang of it, I'd like you to pause the video, and I'll ask you to do this a lot, to pause the video and try these next 2. Or if you still don't get it, you can sit here and listen. But I'm going to tell you that if you listen and if you just watch me do the whole thing, you're going to maybe get a false understanding that you know what's going on, because you're just going to see me do it and do it correctly, well, almost always correctly, and you're not going to actually have practiced it yourself. So I encourage you to pause and try. So now I assume that you're back and you've tried these. You should have some scratch paper by the side. And so we're going to take this first piece and we're going to multiply it by each term. We have our subtraction sign here, so we have 2 terms. So we need to draw 2 arrows, 1 to each term. A third times 6a is 2a. A third times 6 is a 2. And then we have our a, move down our subtraction sign, and a third of 12 is 4. Commit to your answer. Now, what's different about this last one? Well, over here we actually have 3 terms, because we have an addition and an addition sign. So now we need 3 arrows, because this 6 is multiplied by each term. So 6 times a half x is 3x. 6 times 18, we move our plus down. 6 times 3y is 18y. Move our plus down. And 6 times 2/3 z is 4z. And that's distribution. If you have any difficulty with this, please, if you have difficulty, see me. Or comment in video. In YouTube. And I can make more videos. Some of the videos that I make and I've made in the past for other classes come because you ask good questions, and I'm happy to keep making videos on and on to explain concepts more deeply. Again, this is a cursory or quick overview. This is not, I didn't teach you how to do distribution. I didn't teach you all the concepts and all the a lot of the underlying keys, like why is 3 times 4a 12a? You may not even understand that basic piece. That's not something I've taught you here. I'm assuming that you understand how to multiply monomials. If that's something you don't know how to do, see me or comment in the video. Okay, now we're on to the second topic. The second topic here is separating into 2 fractions. Okay, so here the idea is, what is 5x plus 15? There's some mistakes that students will make, and sometimes they'll just say, well, that's equal to, let's just, that's equal to 5x over 5, or x plus 15. They'll do that. That's wrong. That is wrong, and I'll show you why here in a second. The reason that that was wrong is that you have to think about everything on top of this line needs to be divided by 5. It's kind of like you have parentheses here. So I have 5 x's, and then I have 15, the number 15. And that's sitting in a bucket, and I have to divide that 5 ways. I have to divide this whole thing into 5 equal pieces. Well, if I'm going to divide this into 5 equal pieces, I have to divide this by 5, and I have to divide 15 by 5. So think about that. If I divide the x's into 5, that would be x. I've divided 5 equal ways. There's 5 parts. And if I divide 15, like if I had $15 and I had to divide it by 5 people, each one would get $3. Right? So now I have x plus 3. So each person would have x plus 3, x plus 3, x plus 3, and an x plus 3. So this is my 5 equal divisions. So, and now if I take those 5 people who divided up this 5x plus 15 and I put them all back together, I'd get back to where I started. I'd have 5 x's, and I'd have 3 plus 3 plus 3 plus 3 plus 3 plus 3, or 15. So let's undo that for a second and show the quick and dirty way, or the quick way, of how you calculate that. You basically are saying, I have to take each part and divide it by 5. So 5x plus 15 divided by 5 is 5x divided by 5 plus, there's my plus, 15 over 5. And 5x divided by 5 is just x, and then 15 divided by 5 is 3. So let's do the same thing here. Now 2a plus 3 over 2, that does not equal a plus 3. You can't just divide the first ones. You have to say, well, that's 2a divided by 2, and then 3 divided by 2. You have to say it's the whole thing. Each piece, each term needs to be divided by 2. So we get 2a over 2 plus 3 over 2, which is the same thing as, now we can simplify this. 2a over 2 is a plus 3 over 2. Or, if you like, mixed fractions. You could write a plus 1.5. Either one. I'll put my or here. Now, I encourage you to try this last one. And notice we have 3 terms. So I'd like you to pause and try. P plus T, pause and try. All right, I assume you're back. So we're going to take each term and divide it by 4. And now we can't, it's hard to screw this up. 4x over 4 is cancel. You get your x. 2y over 4, well, we're going to divide each one by 2. 1 and 2. And 1y over 2 is just y over 2. And then 20 over 4 is 5. All right, we are through 2 of our 11 pieces. It's going to, again, the video is going to be long, so if you understand certain concepts, you don't have to watch the whole thing. Now, combining like terms. This can screw you up, and this is a key building block. This is so important that you get this right. And the way I like to do this is I like to kind of count out all my terms and identify all my like terms using shapes and enclosing the terms. So what is a like term? A like term is a variable with the same exponent. So let's see here. We have, and in this case, I'm not going to even use exponents. I'm not going to get into the complicated version of combining like terms. We're just going to, we're going to add up all of our x's and add up all of our y's and add up all of our constants. And we're going to put shapes around them. So we're going to choose a box for x's. You could use a triangle, but I'm going to put my x's in boxes. And notice what I'm going to do. I'm going to add in the operator that's in front of it. And then for my y's, I'm going to use a circle. Let's even use a different color. Well, let's not do that. Let's just use a circle. And now I'm going to combine everything that has the same shape. And so now I can see that my x's are in my boxes, and I'm going to say, well, if I have 2 x's and I have 3 x's, how many x's do I have? Well, 2 plus 3 is 5. 5 x's. If I have 2 apples and 3 apples, I have 5 apples. And then if I have 4 oranges and 5 oranges, or 4 y's and 5 y's, I have 9 y's. And there's my answer. Now, I encourage you to try that on these next 2. And remember that numbers are like their own thing. Numbers are like, that you put your own shape. Put triangles around the numbers on this third one, circles around your y's, and maybe squares around your x's. Okay, so I'm encouraging you to pause and try. Here, let's just do these ones in green just because we can. Okay, so on this second one, I'm going to box my x's. And remember, put that operator in front. We're going to circle my y's. So I have 1x, right? If you have an x, that's just like there's a 1 in front of that. 1x and 2 x's is 3 x's. And then if I have minus 2 y's and then positive 6 y's, you have to remember how to add your integers. Negative 2 and 6 is a positive 4y. Negative 2y and 6y is 4 y's. Finally, on this last one, we have three things. So we have our x's. We'll use. Why don't we circle our x's this time? We don't always have to use boxes for x's. Let's circle our x's. And now we'll box maybe our numbers. Let's box our numbers, our constants, because they go in their own section. And then we can put, look at this. I'm going to put a little jagged thing, a jagged circle around my y's, just for fun. I mean, I can use any shape I want. So now I've identified my x's. My x's are, I got 2x and a minus 5x. That's negative 3x. I have a negative 3y and a positive 6y. That's positive 3y. And then a 4 and a negative 7 is a minus 3. And I have combined my like terms. All right, on to number 4. Ordering real numbers. Which is greater? So let's remember what we did in class today. And let's see. How can we think about square roots? So square roots are simply what number times what number is equal to 75. So let's order our square roots. Well, the square root of 1 is the smallest square root. The square root of 2 is the square root of 3, the square root of 4. These are in order. And let's think about what a square root is. A square root is the, well, let me get rid of this for a second while I draw it out. If I have a box like this that is 1 square unit, and then if I have another box here that has 4 square units, because this is a 1, this is a 1, and this is a 1, and this is a 1. What this is saying, what the square root says, is what goes on each side if this were a square to make this have 1. This is square, call it square unit. Well, we know that this would have to be a 1, and this would have to be a 1 to make this a square. All right. Now, if we have 4 square units, then we know that this side would have to be a 2, and this side would have to be a 2, and then we'd have 4 square units, right? Because if this is 1 to here, and then 1 to here, that's 2, and then this is 1 to here and 1 to here, we have 2. And so this is 4 square units. So the square root of 4 is equal to 2, because that means I have to have a box that has a side of 2 will give me a box with 4. And that's all the square. That's why they use the word square root, because they're talking about how you build up a square that has a certain size. So let's think about this. If we have a square that if this is 1 square unit and it has to have a side of 1, and this is 4 square units and that has a side of 2, then if we had a box that has a square units of, say, 2, right? This whole thing is 4. Now let's look at a box that has a size of 1. Well, if we have a box that's between these two sizes, we're going to have this side, we're going to have a square that's 1 here, and all the rest of this is going to add up to 1 more. Okay? So I'm telling you that this has a size of 2 square units. Well, how big is this side here going to be? Well, it's got to be bigger than 1, because that's 1. But it's going to be less than 2, because if we had a side of 2, this whole thing would be 4 square units. But it's not 4 square units, it's 2 square units. So we know that this side has to be between 1 and 2. So in other words, the square root of 2, the side of the square that you need to have to make a box that has 2 square units has to be greater than 1 and less than 2. So that's a geometric way of understanding square roots. Okay, another way to think of it is simply that the square root of 1 is less than the square root of 2, is less than the square root of 3, is less than the square root of 4, is less than the square root of 5, etc. Right? The side of the box that you would need to make a box that has 1 square unit has a size of 1. The side of a square that's needed to make a box that has 4 square units is 2. So the side of a box that's needed to make square root 2 square units is between 1 and 2. And the side of the box that's needed to make 3 square units is between 1 and 2, but greater than the side that would make a box that's 2 square units. Okay. Let's use that principle right here and say, well, the side, what is 9 equal to? Well, 9 is equal to the square root of 81. Right? So 9 equals the square root of 81. So what's bigger? The square root of 75 or 9? Well, the square root of 75 is the square root of 75. The square root of 81 is bigger than the square root of 75. So 9, which is equal to the square root of 81, is bigger than the square root of 75. So you'd write your answer like this. You'd say, well, the square root of 75 is less than 9. So let's do that here. What's bigger? The square root of 6, the square root of 3, or the square root of 12? Well, we can't compare these three. So let's write them all as square roots. Well, these are already written as square roots. So let's write 3 as a square root. Well, 3 we know is the square root of 9, because a square that has 9 square units would have a side of 3. So now we can write our inequality. The square root of 6 is less than the square root of 9, is less than the square root of 12. But we asked about the number 3. So let's just replace this and say, well, it's 3 less than the square root of 6 is less than the square root of 12. Again, why? Because we can order these numbers because they're all inside square roots. So that's the idea to ordering real numbers when you're dealing with integers and dealing with square roots. Let's move along. We are taking some time. Order of operations. This is just these are just practice. I want you to just, remember, we do PEMDAS is one way. Please excuse my dear PEMDAS, Aunt Sally. And this isn't exactly right because multiplication and division, these go together. And then addition and subtraction go together. So these go left to right. So if you have multiplication and division, one isn't more important than the other. They go at the same time. This is left to right, and addition and subtraction is also left to right. Okay, so let's see. Do I have parentheses? I'm gonna say pause and try now. Pause and try all of these, and then I'm gonna run through them one at a time. Okay. Well, now I'm back. Hopefully you've tried these all. I really hope you did. There's no parentheses in this first one, no exponents. Multiplication, yes. So we have to do the multiplication before the subtraction. So we say, well, that's 2 minus 6. And now we can do the subtraction. So we have minus 4. Over here, parentheses, no. Exponents, yes. We have our exponent here. So we go 1 plus 16, and so our answer is 17. All right, down here, parentheses, exponent. Okay, well, let's do our parentheses first. Do this one first. So we have 6 squared over 3 minus 10. Well, next we have exponents, so there's our exponent. 36 over 3 minus 10. No more parentheses or exponents. Now multiplication and division, so we'll do that next. 12 minus 10. And so now we only have subtraction left, so that's 2. Okay, and then our last one, multiplication, no parentheses or exponents. Multiplication and division, yes. So we have these two multiplications. We can do those at the same time. 8 minus 3, and all we have left is subtraction, so we have 5. If you have any difficulty with order of operations, go to the book. There's a lot of practice in the book. Okay, moving along. Multi-step operations. Now, these are easy for some and a little tricky for others, so let's just look at the difference. These are actually, these two have the same operations going on, right? There's a multiplication, there's an addition, an equality, and they have the same numbers actually, but they evaluate differently. And how do you know how to solve each of these equations? Well, we need to undo, if we're solving for x, we're trying to find x, we have to kind of undo the operations that we have mixed in with the x. Over here we have a multiplication and addition. And remember, to undo various operations, to undo addition, we use subtraction. To undo subtraction, we use addition, because those are opposite, or inverse operations. To undo multiplication, we use division, and to undo division, we use multiplication. And the way that we do them is we have to undo them in the order that we apply them to the expression. So let's look at this. Here, we took an x, and then we added 4, and then the second thing we did is we multiplied by 2. That's what we did. So to undo it, we have to undo in the opposite direction. So now we have to go first, we have to undo the second operation. So we divide by 2, because that's the opposite of multiplication. And then second, we have to subtract 4. So let's see how this works. So this is what we did, and this is what the operations that appear here. And these are the operations that we must do. So I'm going to rewrite the problem here. 2x plus 4 equals 2 times the quantity x plus 4 equals 16. So we got to divide by 2. And when we divide by 2, we have to do it to both sides. We must do to both sides. So we're going to cancel our 2's, and we're going to end up with x plus 4. And on the right side, we get 8. So we've done our divide by 2. Now we got to subtract 4 from both sides. So here we get x equals 4. Let me just separate this out. Now what I want to do is I want to check my answer. And so I'll check it in green here. And we check our answer. We're going to take our 4 and we're going to plug it back into the original equation. And so if x is 4, we want to make sure this works. 2 times 4 plus 4, that's our x is 4. Does that equal 16? Well, 4 plus 4 is 8. 2 times 8 equals 16. Yes. So our answer is correct. Now here on the second problem, what did we do? We took our x and the operations on the left side here. We multiplied by 2. And then the second thing is we added 4. So this was different. Before we added 4 and then we divided and then we multiplied by 2. On this one, we multiply by 2 first, and then we add 4. That's our order of operations. So to undo that, we need to first undo our plus 4. We need to subtract 4. And then second, we need to divide by 2. That's how we undo multiplication. So let's write that here. 2x plus 4 equals 16. And this is what we have to do. Well, let's subtract 4 from both sides. So that cancels. 2x equals 12. Now we have to divide both sides by 2. And we get x equals 6. Now let's check our answer. Take our 6 and plug it back in for x. And rewrite the equation. 2 times 6 plus 4, does that equal 16? 2 times 6 is 12, plus 4 equals 16. So that's true. So our answer works. All right. Now the other kind of multi-step operation that's very basic building block is this ratio setting. So on ratio, when we have a ratio, we have two fractions that are set equal to each other. The key is cross multiplication. So we're going to multiply the top of the numerator of one side by the denominator of the other side, 3 times 12, and that equals the denominator of the other side, the first side, times the numerator of the second side. So we get 36 equals 4x. Now we divide both sides by 4, and we get x equals 9. Similarly, on this side, we do our cross multiplication. You might want to pause and try this one. So we get 15x equals 5 times x plus 4. Well, let's look here. On this left side, we can do two things. We can either distribute, or we can say, well, solving for x, we had to, we add 4, then second we we multiply by 5. So to undo that, we need to 1, divide by 5, and 2, subtract 4. So let's do it that way first. We're going to divide by 5, divide both sides by 5. We get 3x equals x plus 4. And then, well, now we have to combine like terms. So we're not going to do the subtract 4 side. We have 3x equals x plus 4. So we got to combine our x's. So let's see. We got to subtract an x from both sides to simplify. 2x equals 4. So x equals 2. Now we could have done this a different way. So let's just do this using the distribution strategy. So here we get 15x. And then we'll distribute here first. So we get 5x plus 20. Subtract 5x from both sides. 10x equals 20. Divide by 10. And we get x equals 2 as well. Okay, so that's multi-step operations. You give some good examples. Again, if you struggle with this, there's some problems in the book, come see me or ask specific questions and I can do them more in depth. All right, moving along. Okay, inequalities. Now the whole key to inequalities is you solve them exactly as you would inequality. You do the exact same thing. Just pretend that's an equal sign, and then just solve it. Except for one thing. Pretend it's an equal sign, except for one thing, and that's if you ever multiply or divide by a negative number, you have to flip this sign. Change less thans to greater thans to less thans, greater than or equal to less than or equal to, and less than or equal to greater than or equal to. So you kind of flip this, what I call change the sign. You can think of it as flipping the sign. You just flip the arrow the other way. But if it's a greater than or equal, you need to leave the equality if it has that equal sign. And if it doesn't have an equal sign, you don't add an equal sign. So let's do it. So we're just going to pretend this is an equal sign. And what would we do? We would add 2 to both sides. So we'd get 3x is greater than 21. And now we're going to divide both sides by 3. Greater than 7. And how do we graph that? Just to go to the next step, we're going to we'll put our 7 in the middle, 6, 8, and because it's a greater than, we use a hollow circle, and then we draw a solid bar in the same direction, inequality sign. And there's our answer. So that's saying that any greater than 7, not including 7, will work in this inequality. So if we use the number 9 or 10, it'll make this true. We'll put a 10 in for x because 10 is true. It's all this dark stuff will make this true. So does 3 times 10, which we think should work, minus 2, is that greater than 19? Is 30 minus 2 greater than 19? Is 28 greater than 19? Yes, it is. And we know that numbers over here should not work. Numbers like 5 all the way down, maybe even 0. None of these should not work, and these should work. So let's try 0 up here and see what happens. It shouldn't work. It should make it false. 3 times 0 minus 2, is that greater than 19? 3 times 0 is 0, minus 2. Is minus 2 greater than 19? No. So this is so we have our correct answer here. All right, let's solve this one in orange. All right, so now let's look at this guy here. Well, 3/5 x is less than or equal to x plus 2. So let me use a strategy that I like whenever I see fractions in problems. I'm just going to multiply both sides by 5 to get rid of the fraction. Because I can multiply both sides by 5. 5 times 3/5 is 3x. Is less than or equal to distribution 5x plus 10. How can I do that? This backwards distribution? Well, x plus 2 times 5 is equal to 5 times x plus 2, right? Something times something else is equal to the second thing times the first thing, right? 3 times 4 equals 4 times 3. We know that's true. So x plus 2 times 5 is the same as 5 times x plus 2. So there's our distribution. So don't let this fact that I'm drawing these arrows backwards confuse you. Okay, so now I'm going to subtract 5x to get all my x's on the left. Is less than or equal to 10. So when I do subtraction, I can subtract and add positive and negative numbers. And I don't flip my sign for adding or subtracting. Right? We only flip the sign when we multiply or divide, not when adding or subtracting. Okay. One more point. Whenever we're doing inequalities, try to move the variable to the left. Always have your variable on the left. It'll make your graphing so much easier. Okay. So now we have to divide both sides by -2. So if we divide by -2, what do we have to do? If we multiply or divide by a negative number, we have to change the sign. So now we have x is greater than or equal to, right? If we have less than or equal to, it becomes a Greater than or equal to becomes a less than or equal to. Less than or equal to becomes greater than or equal to. So x is greater than or equal to -5. And how do we graph that? Well, we're going to draw our graph, put our -5 in the middle. Over here is -6. Over here is -4. Over here is 0. So we put a solid circle because 5 works. And then everything greater because the arrow's pointing to the right. So let's try some numbers. Let's try 0. So is 3/5 of 0 less than or equal to 0 plus 2? Well, is 0 less than or equal to 2? Yes. So this works. And it looks like we have a valid graph here. We can also try a number like -10. Let's try -10 and make sure that it doesn't work. Well, it's 3/5 times -10. Is that less than or equal to -10 plus 2? Well, is -6. Is that less than or equal to -8? No, it's not. So we know that we probably have a correct graph. Okay, so that's inequalities. Again, I know we're going fast. I'm not fully teaching you all of these concepts. That's not the point of today. It's just to review some of the key concepts, remind you of how these problems are done. And if you struggle with any of these concepts, then we're going to have to get you all caught up on how to do these problems or identify some problems in the book that you can work on to improve your skill at math. All right, absolute value equations. Now, these are hard for some people, but let's see if we can break it down. These are always two-step problems. And what you're going to do is you're going to pretend like the absolute value is a variable, and you're going to solve for it, just like you would x or y. You're going to solve for this. You're going to solve for this. And this one's already solved for them. And then you're going to build two equations, one with the negative and one with the positive value, and then you're going to solve. And you're going to get two answers, generally two answers. All right, so this one's already solved for 9. So what we're going to do is what's true about this equation? Well, if the absolute value of x plus 1 is 9, then I know that what's inside here has to be equal to -9 or 9. Right? If it's equal to 9, then the absolute value of 9 is 9, but the absolute value of -9 is also 9. So how do I solve from here? I write my two equations. I say, well, x plus 1 equals 9, or x plus 1 equals -9. And then I solve both. Well, this one solves, if we subtract 1 from both sides, I get x equals 8. And before you go and say comes out to x equals -8, that's not right. We got to subtract 1 from both sides. And you get x equals -10. So the answer is x is 8 or -10. So let's write that in set notation. X equals, well, let me put my bracket notation, I should say. -10, this lower number first, smaller number first, comma 8. Right, so let's try both answers out. -10 plus 1, the absolute value equals 9. Well, -10 plus 1 is -9. Absolute value of -9 equals 9. Check. Well, and let's try the other one. Absolute value of 8 plus 1 equals 9. Does it equal 9? Well, is the absolute value of 9 equal to 9? Yes. Okay, so over here, we have to use step 1. Over here, we had already solved for the absolute value. But over here, the absolute value isn't solved for. So let's treat this thing as a variable and isolate it on the left. So pretend if this was 2x equals 10, what would we do? Well, we'd divide both sides by 2, and we'd get x equals 5. Similarly, on this guy, we're going to weave this all together like it's parenthesized, like it's its own variable, and we're going to divide both sides by 2. And so then you cancel your 2's, and you get the absolute value of y minus 3 equals 5. Now that we have our absolute value isolated, we can now split into 2 equations. And we get y minus 3 equals 5, or y minus 3 equals negative 5. And here we're going to add 3, y equals 8, or y equals add 3, minus 2. So y equals smallest first, minus 2, comma 8. It can equal either one. And we can check it out up here, and we can say, well, negative 2 minus 3 is 5, negative 5. Absolute value of minus 5 is 5. 5 times 2 is 10. 8. 8 minus 3 is 5. The absolute value of 5 is 5 times 2 is 10. So we have our answer checked out. Again, that's how we do our absolute value equations. If you want, let's just do one more to get it even more advanced. Let's just do a quick one here. And you can try this one out on your own. And then I'll solve it really quickly. So let's go 3 times x plus 1 minus 7 equals 2. Okay? Well, this one, again, treat this like a variable. And what are we going to need to do? We're going to need to add 7 to both sides and then divide by 3. So we're going to add 7. 3 times x plus 1 equals 9. Divide both sides by 3. And so now we've solved for our absolute value. Now we get x plus 1 equals 3, or x plus 1 equals minus 3. So here we get minus 1, x equals 2, or minus 1, x equals negative 4, x equals minus 4, comma 2. All right, let's move on. We just got 3 topics left. Hang in there. Or just take a break. Take a break and come back. Or maybe you understand everything just fine and you're done for the day. Okay, so we want to solve now for x. And the way that we do this is it's just the same thing. We want to solve for x. We're not going to get an answer. If we ever have 2 variables in a problem, we can't solve for x. We can't find out the number that x equals, because x can be a number of things depending upon what y equals. But we can still use all the same operations. So what we want to do is we want to get x, we want to get x by itself. So we do that using the same strategies as before. So what did we do? We multiplied by 3, and then we added 6y, so we have to undo that. So we're going to undo the second thing first. If that doesn't make any sense, you might just know how to just subtract 6y from both sides. And now we have 3x equals 12 minus 6y, right? We're doing the same types of operations to both sides. We're using our subtraction property, multiplication, division properties of equality, but we're not going to get a number for an answer. So now we have 3x equals 12 minus 6y. Now we need to divide both sides by 3. And so on the left side, we get x. And on the right side, remember, here we have, go back to step 2, lesson 2 from today on these slides. This is equal to, You know, if we have a fraction that's dividing this piece, this top piece by 3, we have to divide both terms by 3. So that's 12 over 3 minus 6y over 3. So that's equal to 4 minus 2y. And so now that's called, we've solved for x. We have x by itself. Okay. Now let's do the same thing. We're going to solve for m. Well, what does this look like? This looks like we cross multiply. So let's start by cross multiplying. We get 4n on one side, and on the other side we get 5. And remember, we got to multiply that 5 by the whole numerator, m plus 7. So 4n equals 5m plus 35. We want to get this m by itself, so let's get all these numbers off the right side. So let's start by subtracting 35. 4n minus 35 is 4n minus 35. You can't combine those terms. And that equals 5m. Now we're going to divide both sides by 5. And on the right side we get m. And on the left side, remember, 4n over 5. Got to divide 5 by both pieces. 35 over 5. So we get 4n over 5 minus 7 equals m. Now we like, when we say solve for m, we like to put the m on the left side. So if one thing equals another, then the second thing equals the first, right? It's called the reflexive property. So we can just, switch sides and say m is equal to 4n over 5 minus 7. So that's rearranging formulas. That was very quick. Again, there's a lot of practice you can do. We did some practice in class, and you should do some practice at home if this is something that you struggle with. This is something you do a lot of in algebra, especially when you start graphing linear equations. So this is something you should be quite comfortable with. All right, percent problems. Now these are so hard for some people. If you ask your mom or dad or your friend to solve one of these problems, they would struggle to get all 3 of these right, I guarantee it. But let me tell you the whole key to these problems. It's called translation. Is means equals. Of means multiply. But at the same time, before you do anything, the other key is you need to convert percentages to decimals. So remember, to convert a decimal to a percentage to a decimal, you take the number, and to convert it to a decimal, you just move the decimal point 2 to the left. So 50% is the same thing as 0.5. Right? If you don't know how to convert decimals to, or numbers to decimals and decimals to numbers, you need to practice that. You need to learn how to do that. Come see me. So now that we know how to do this, let's just take our is and turn it into an equal sign. We're going to take this whole math sentence and just convert it into a math expression. Of is multiply. Now we just take numbers and move them down. We take what's and turn them into variables, and we take percentages and we turn them into numbers. Okay, so 14 is a number, so we just put our 14 down. 50% is the same thing as 0.5. And then what number is x? If you see what number, that's the thing we're looking for. So that's x. So we say 14 equals 0.5x. So let's divide both sides by 0.5. And 14 divided by 0.5 is 28. If you don't know how to do that, you need to come see me. That's 14 divided by 0.5. Before you divide, you have to make sure this number you move that decimal to here. 5 into 14 is 2. 2 times 5 is 10. 45 into 40 is 8. 8 times 5 is 40. So we have 28. So that's how you do it. Another way to have done this would have been to say, well, 14 equals a half x, because 0.5 is a half x. Now you just multiply both sides by 2. 2 times 14 is 28 equals x. Okay. You should be comfortable with this kind of long division. That's a 7th grade building block. All right. Now, what is 40% of 20? Let's do the same thing. Is equals. Of is multiply. 40% is 0.4. 20 is 20. And what is x? So we have x is 0.4 times 20. Well, 0.4 times 20 is equal to 8. So x equals 8. You should know how to multiply 0.4 times 20. All right, 6 is what percent of 4? Well, here we go. Well, our what percent is x. And notice we're going to have, because it's a percentage, we're going to have to convert that back at the end. 6 equals x times 4. So 6 is equal to x times 4. So 6 equals 4x by 4 equals 1.5. Well, it's not 1.5%. 1.5 is the number, right? And if we're solving for a percent, we need to convert to a percent at the end. So 1.5 is a percent. We have to move 2 to the right. 5 is 150%. So 6 is 150% of 4. And that's our percent problems. Lots of practice will make you perfect at this. Key is this circling and doing your doing your arrows, and you really can always set things up correctly. And always remember this last thing. If you're solving for a percentage and you get this, you come down here and you say x is 1.5, well, you need to make sure you answer it as a percent if you want full credit. All right, we're down to the last topic. Oh my goodness, these were a lot of topics. Again, I'm not going to tell you this is a situation where practice makes perfect, but we're going to take word problems and we're going to write them as expressions in equations and then solve. We have to be able to take words and convert them into math. So here's an example. You're a coach and you have $810 to buy cleats and soccer balls for your 12-student soccer team. $30 each, and cleats cost some amount. You're not sure how much. So we're just going to call that X. We're going to say cleats cost X. So one pair of cleats, one will cost 1x, 2 will cost 2x, 3 will cost 3x, and 4 will cost 4x, et cetera, et cetera. All right, this is your cost. This is your cleats. And this is your cost. Okay, so write an expression for the cost of 3 soccer balls and 12 pair of cleats. Well, if you know how to do this, I encourage you to try this right now. Even if you get it wrong, I won't know. You will at least know yourself whether you're confident or not. If you get this right, you're on the right track. If you just think you know and you don't write it down and watch me do it, you'll never really know. So 3 soccer balls. 3 soccer balls, well, if one is 30, then 3 is 3 times 30. Well, 12 pair of cleats. We don't know how much 12 pair of cleats cost. We just, each pair of cleats is X. 12X. So you can simplify this and you can say, well, that's 90 plus 12X, which is the same thing as 12X plus 90. We usually like to put our variables first. So let's set it equal to what? 810. How much we're going to spend, and we have $810. So let's write an equation and say, well, 12x plus 90 equals $810. See how much expression, and now let's solve. Minus 90 20. Divide by 12, and I get x equals $60. And $90 on soccer balls, I will spend $810. So what if now let me ask you a different question. You know, what if cleats, I have three kinds. They cost either $30, $50, or C, $75. Which ones can I buy? Which ones can I buy? Well, the answer is, well, I can buy $30 cleats, $50 cleats, but I cannot buy $75 cleats because I don't have enough money for my 810. Okay, so this is, we've gone over all of our topics. Wow, long video. We've gone over every single topic that might be on the quiz tomorrow. But what's more important is not what you're going to score on your quiz, are your building blocks for algebra. It is expected that you know how to do all of this stuff. You need to know this in order to be successful in this class. So if you struggle on any of this, know that you're getting an A on your quiz tomorrow, but for your day 2 quiz, but you're going to need to study it because it's going to come over and over and over again for the next 3 weeks, and then again in the part 2 of the course for the second 3 weeks. So hopefully this was a useful exercise. I want to make sure that you comment. If you struggle, if you love this, please thumbs up me. If you struggled, feel free. I encourage you to write a note or write a comment in the video, in the YouTube feed, to give me an idea of how I can help you better. Maybe I can go over order of operations, or maybe I can go over 2-step equations better, or maybe we can spend some more time in class, or I can do a separate video on any one of these topics. Let me know. First, good or bad, and I'll be seeing you in class. Take care.